Now, there are some special cases that happen with these graphs or equations that sometimes you don't get a point of intersection.
Right.
Which would be no solution.
You get some really wacky thing that occurs.
Yeah. Sometimes they just don't intersect. That would be no solution. Or sometimes they intersect so well, like they overlap, and they are the exact same graph.
That's really, really well intersected.
Yes, that's a really great intersection, is if you intersect all the time. So that is the case of infinitely many solutions. And so the way that you know which case is happening is on your answer, if you get a variable like x, if x equals 5, it solves normally and your graphs intersect somewhere, 5 comma something, okay?
Right.
If you end up with an answer of no solution, what that looks like is that the variables will cancel out as you're working through it, and what you were left with is a false statement. So you might end up with something like 0 equals 5.
Right. That's absolutely not true, so don't even try and justify that.
Right.
The other thing with that one that comes up where students make mistakes is they'll say that -1 equals 1, and they'll let that one slide.
Yeah, but no, that -1 does not equal 1.
They're not the same, and they never will be.
Yeah, so I said on this graphically that it's parallel lines. That's if you have 2 lines. You could have 2 other graphs, like you could have a circle and a line and they not intersect,
right.
So you would have no solution there.
2 parabolas that may not ever intersect.
Yeah, so infinitely many solutions, what happens is the variables cancel out and what you're left with is a true statement. So what happens there is you're allowed to plug in any number you want and you'll still end up with a true answer. And so you'll end up with like 5 equals 5 or something.
Or 17 equals 17, or even 0 equals 0. That's
right.
a true statement.
Right. So on examples 4 and 5 here, it lets us pick using substitution or elimination. These are going to give us either no solution or infinitely many solutions just to make sure we understand what's going to happen. The first one I'd like to substitute just for practice, and then the second one eliminate.
You know, that sounds great. One of each.
Yeah, this is actually the better one to substitute on, because if you subtract 2x over to this side,
we have a y equals statement.
Yeah.
And if you'll notice on the example 5, there's going to be more to it than just subtract the number over. Like if you just eyeball it, you don't have to solve it out. But if you look at example 5, there's more than just subtract a number.
Trying to get x by itself or y by itself is going to give you
it's going to take
fractions.
at least 2 steps, yeah.
And so let's distribute. So that's -14 plus 4x equals -14. So notice what happens here. We have -4x plus 4x, which is 0.
Hey, those things could go away.
So if we just go ahead and write this down, -14 equals -14. Is that true?
That's true. And so if it's true, then that means that these are the exact same line.
Right.
So that means there's infinitely many solutions. Okay, and it's okay to get a statement like this. Like,
yes,
if you get a statement like this, don't freak out and think you got the problem wrong.
Right. On the second one here, if we do elimination, I notice that these numbers are smaller, so that's where I should multiply. I'm going to multiply by 5, try to get rid of the x's.
Good plan.
And with elimination, if it's an issue, it's going to be really quickly obvious that we've got a problem here. Did I do that right?
I think so. You multiplied everything by 5, so that's
Okay.
good. So that goes, that goes, that goes.
Oh, this one's infinitely many solutions too.
Oh, look at there, infinitely many.
What did I do? I thought one of these was going to be
Well,
no solution.
I thought one was going to be, but you did everything correctly. So that one also, 0 equals 0 is infinitely many solutions. So if you get that, don't sweat it.
Okay.
Yeah.
Okay, cool.
All right. If you don't want infinitely many solutions, take the bottom equation and make it equal 10.
Yeah. Yeah, and then solve it out and see what happens.
And then solve it out and see what happens.
You'll get 0 equals
something.
15 or
something like that.
35 or something.
Right.
So that would be no solution.
Yeah. And that's not true.
Yeah.